Okay, good afternoon. So you're now in the second half of the intersession module-wise, and the next and last quiz will cover modules 4, 5, and 6. Now, I've talked to the other teacher, and we might not have the second quiz as departmental, and we might cut or omit some topics so as to give you more focus on studying the more important ones, which I will be announcing in Canvas, okay, which topics will be included in the second quiz. Now, for the first quiz, I haven't actually finished checking your digital papers or your answers in Canvas. I have actually only checked the other sections papers. But I'll try to finish yours by, if not today, tomorrow or Wednesday at the latest. And then I will be showing the answers in Canvas. And once I do so, you will be given 2 days to report any errors in the checking, and in case possibly wrong answers given in the platform, okay, in Canvas. Now, module 4 starts with inverse functions, and then exponential functions, logarithmic functions, then exponential and logarithmic equations. Now, as stipulated in the syllabus and as also discussed in the first session and repeated over and over again, you are expected to have read all the topics just before we discuss the exercises during Mondays, Wednesdays, and Fridays. So I will begin answering some problems on exponential equations, the simple ones. And then I will just reserve discussion of inverse functions once I've done exercises on logarithmic equations as well, so that we just have to discuss inverse exercises on inverse functions one time. Okay, so here we have an example of an exponential equation which can be solved by converting both sides of the equation to the same base. Now later, when we go to logarithms, we can use logarithms to solve those exponential equations where you cannot convert to the same base. Like, for example, suppose you want to solve, say, 2 to the x equals 3 to the x plus 1. And this is a solution. You cannot do so by converting to the same base, since 2 and 3 do not have a common base in terms of whole or numbers or integers. So for this type, you will have to resort to logarithms. But sometimes you can solve an exponential equation by just converting to the same base, as in the one given there. 4 and 8 have a common base. Both can be expressed in base 2. 4 is 2 squared, and 8 is 2 cubed. So we can rewrite that equation as follows. Okay, there. And apply some of the properties of exponents that you are already familiar with from high school. I can just quickly give you some of those properties that are needed for this particular example. The property that a to the m to the n is equal to a to the mn. That is, if you have an exponent within an exponent, then you can just multiply the exponents. Okay? And that's what we will be applying to the line there, here, this line, by multiplying the exponents, those expressions. So we will have 2 to the 2 times x plus 1 equals 2 to the 3 times x squared minus 1. And so we can solve this equation by just comparing and equating the exponents, since they already have the same base 2. So for the 2 to be equal, their exponents must also be equal. So we set 2 times x plus 1 equals 3 times x squared minus 1. And solve for x. And this is just now a common algebraic equation. Actually, it's a quadratic equation. So you just do it the usual way. Do algebra. Factor out after you have put everything on one side of the equation, or use the quadratic formula to solve the equation. Wait lang ah. There. Okay, so you can try. Okay, if I were to factor this out, I would think of factors of negative 15, 3 times negative 5, that add up to negative 2. And that would be negative 5 and 3. Then group. So if you factor out, you can just do trial and error. You'll get x equals negative 1 or x equals 5 over 3 as solutions to the quadratic equation there, and thus solutions to the exponential original equation as well. This one. Any question on this example? Okay, next. Okay, let's read the problem there. 3 to the 2x minus 1 equals 243 all over 9 to the x minus 3. Now, same technique will apply to this equation here, we convert to the same base. First note that 9 is 3 squared and 243 is also a power of 3. The powers of 3 are 3, 9, 27, 81, and the next is 243, which is 3 to the 5. So we'll write everything in base 3. The left-hand side is already in base 3. Numerator is 3 to the 5. And then denominator is 3 squared to the x minus 3. And again, you apply the properties. One of the property of exponents, multiply. So we can write as 3 to the 2x minus 1 equals 3 to the 5 over 3 to the 2x minus 6. And then another property of exponents is needed to simplify the right-hand side of this equation. And that is this one, where states that dividing exponents, okay, is simplified by subtracting the exponents. I mean, exponentials here, if you divide a to the m by a to the n, then we just subtract the exponents. So a to the m over a to the n equals a to the m minus n, which we use to simplify this one, to combine into one base. So we will have the right-hand side as 3 to the 2x minus 1 equals 3 to the 5 minus 2x minus 6. And then simplify the exponent there. So this becomes 3 to the 2x minus 1 equals 3 to the negative 2x, and then 5 plus 6 equals 11. Okay, distribute the minus sign, of course. Now, you compare the exponents, equate the two. So we have now just simply a linear equation. 2x minus 1 equals negative 2x plus 11. And then solve for x. We'll get x equals 3. Any question on this one? So basically, the thing here is to convert to the same base. Now, how do you solve this one? Well, it seems that this one is a little more complicated than those we have seen so far, but actually, since we just have a 0 on the other side of the equation, then the simplest thing to do here would be to transpose the other term to the one of the terms to the other side. So you'll just have that, and you see that they already have the same base. So all you have to do is just equate their exponents, and you get x equals 1. So napakabilis lang actually nito. There. Any question on this? Now, if you don't have a 0 on the right-hand side, then that's when you try to manipulate the equation algebraically. So how do we solve this one? Anyone has any idea? If you studied the material or tried some of the problems given in the module, you may already know how to solve this one. Now, by the way, E is not a variable there. It's actually a constant, like pi, which is 3.1415. Now, in the video lectures and in the reading materials, you are it is explained there how E was derived, and approximately it's 2.71828, 1828, or to just 3 decimal places, 2.718. Okay, so it's just like your pi. And we call this the natural number. And so we call this the natural exponential function, e to the x. Okay, so think of e as just a constant there. How do you solve the equation? Now you have to convert this first into an algebraic equation that you are familiar with by using a what do you call this, transformation, a dummy variable. That's how mathematicians call the new variable that is introduced to solve this or to make this equation simpler and thus solvable. Let t, so this is our t or our dummy variable t, and we let it be equal to e to the x, so that is our transformation, so that the original equation will be converted to a simpler algebraic equation in the new variable t. Now we can rewrite first the original equation as e to the x plus 1 over e to the x equals 2. Remember, a to the negative n, this is one definition of exponents given, okay, actually taught already in high school and given in the materials, where a negative exponent is introduced by defining it to be the reciprocal of a positive exponent. So a to the negative n is the reciprocal of a to the n. Okay, so e to the negative x is the reciprocal of e to the x. And notice that e to the x is a common expression. And that's how we chose our dummy variable t. And so if written in terms of t, it just becomes like a common algebraic equation encountered in high school. T plus 1 over t equals 2. And how do you solve an algebraic equation like this? Well, you already know how to solve a quadratic equation, but this does not seem to be a quadratic equation, but actually it can be converted into one by manipulating that equation. We will multiply both sides of the equation by t so as to temporarily remove the fractional terms in the equation. Okay, multiply everything by t. So we have now t squared plus 1 equals 2t. And then it becomes quadratic. Okay, after transposition, we have a quadratic expression here that's actually factorable, and it's actually a perfect square. It's just t minus 1 quantity squared. And so if you solve for t, you get only one solution, t equals 1. And take note that this is also a solution to this original algebraic equation, since t is substitutable into it. What I mean is that suppose that in the process you get t equals 0, then it will solve, it is a solution to the resulting equation after multiplication by t, but it will not be a solution to the original algebraic equation there, since you cannot plug in 0 for t. Division by 0 is not defined. But anyway, we got t equals 1. Now, you just have to check if it's in the domain of the original algebraic equation. So it is, and therefore it is also a solution to that. But this is not yet the final answer, since we actually are solving for an exponential equation. We have just solved the transformed equation there. So we have to revert back to the original variable x. And again, we use the transformation there. T equals e to the x. So we have e to the x equals 1. And how will an exponential become equal to unity or 1? Becomes 1 only if the exponent is 0. Any number, remember, raised to 0, or any expression raised to 0, any number raised to 0 is 1. And no other exponent can do that. In other words, x here is 0. So e to the 0 is 1. You can check. Therefore, x equals 0 is the only solution to the exponential equation. In fact, you can check your answer. If you plug in 0, see, e to the 0 plus e to the negative 0 is 1 plus 1. Anything raised to 0 is 1, so 2. Now, of course, if this were an upload or a show your solution question, you cannot just give the answer of 0 by guessing, or by first trying out some possibilities and by chance getting a correct answer. You have to show all pertinent solutions. Any question on this before I proceed again with the next? So actually, section 2 na ito ng module 4. Ini-skip ko muna yung inverse functions, sinabi ko naman kanina. So all of the equations we have solved so far are convertible to the same base, and so is this one. However, it will be a little bit different in approach, since we have a trinomial, or what they call this, a term or an expression that has 3 terms. So first, we convert to the same base. Observe 9 and 3 are the bases in the exponential equation here. So we can convert 9 to base 3. 9 is 3 squared. And then multiply the exponents there. So this becomes 3 to the 2x, multiply. And then 3 is a common base now. Except that, of course, the exponents are different, and there are several terms in the one side of the equation. So the same technique will be used to solve this one. We use a transformation. Let t be equal to 3 to the x. So this is one of the techniques you'll be needing to learn in order to solve some of the exponential and sometimes even some of the logarithmic equations, as we shall see later on this week. So with that, we can first rewrite the original as follows: 3 times t squared. Why did it become t squared? Well, this one here is actually the same. Okay, it's 3 squared to the x, right? And we simplified that as 3 to the 2x, but we can also write it as 3 to the x quantity squared. Multiply x and 2, you still have 2x. And we denoted 3 to the x by t, so that's actually just t squared. Okay, you can verify anyway by just checking t squared, since t is 3 to the x, is 3 to the x squared, so multiply, you have 3 to the 2x, which is this term. So we have 3t squared plus 5t minus 2. And there, you see, it's actually quadratic in t, or quadratic in 3 to the x, but it does not appear to be so right away. You only see it once you use a transformation or a dummy variable. First, you have to solve, of course, the quadratic there. So, try natin naman yung trial and error ng pag-factor out. Yung 3t squared has only one possible combination, 3t and t, and 2 is also prime. So, either 1, 2 here, or 2, 1 here. So, let's try that. Will we get 5t? 1t and 6t, it's possible to get, okay, if you subtract, to get 5t. So, paano natin makukuha si 5t? Positive 5t siya. So, we will have to put minus here, plus here, correct? Minus t and 6t make up 5t, and check, negative 1 times 2 is negative 2. Kailangan negative din yung lumabas. So, sa first try, nakuha natin agad. Of course, sometimes, hindi mo agad makukuha yon. So, try another combination. And so, we get t equals, if you equate each factor to 0, 1, third, and negative 2. So, solve for t na siya. We just have to solve for x. So, again, use the transformation given. So, you have two cases. 3 to the x equals 1/3, and then 3 to the x equals negative 2. Now, let's tackle the first one first. I mean this one. So, how do you solve that? 3 to the x equals 1/3. Well, you can convert 1/3 to base 3 as 3 to the negative 1, right? It's just the reciprocal of 3. And then equate the exponents. So you quickly get x equals negative 1. Or you can just right away give the answer, since you know 1/3 is 3 to the negative 1. That's for t equals 1/3. For t equals negative 2, actually there's no solution, since one of the properties of exponentials is that they are non-negative, or actually positive. Any exponential function or expression is greater than 0, always. An exponential can never be negative, it can never be 0. In fact, when you study the domain of exponential functions, their domain is the interval 0 to infinity, set of positive numbers. In other words, you can never make it negative, nor can you make it exactly equal to 0. So what this means is that this has no solution. Why? Again, an exponential is positive, and you're setting it equal to a negative number. That's impossible. So you have only one answer. So you can either leave it like that or use delimiters to write down all your answers. And there's only one, so you just have that. Any question again? Wala pa rin? Okay, I'll give you 5 minutes to try this one out para naman active din kayo, ano? And matest natin or matest ninyo kung nakuha natin yung discussion at kung anong technique din. Isipan nyo kung anong technique yung gagamitin dito. So you take a look at that and see if you first have to manipulate it, or you can directly tackle it, or if you have to use a transformation first. Okay, so sige, 5 minutes, babalik ako. Okay. Now there are actually several approaches. You can first use a transformation, t equals 5 to the x. You can do that right away. But you can also first manipulate the equation, which I will be doing. So I'll multiply or cross multiply. Okay, it's like 3 over 1, cross multiply. You get the following. Okay, and then simplify. Distribute 3 first to simplify the right hand side. It's 9. And then you combine like terms. Now I will be transposing. Bahala naman kayo, no? Sa inyo yung saan kayo mas sanay. But I will be transposing this one here. And then this one here. Okay. So I'll be having this. So negative 9 becomes positive 9. And then this one has a 1. You have 10 times 5 to the negative x. And then this one here, transpose, you'll have 3 minus 1. So 2 times 5 to the x. Now, some might first use a transformation here. You can still try that. It will still work. T equals 5 to the x. And then 1 is 1 over t. This one is t. And this is the reciprocal of t. However, we can just manipulate this further by dividing, okay, everything by 5 to the negative x. I'll be putting it down. Then this one down. In other words, I'll be dividing by 2 times 5 to the negative x. Or, sige, isa-isay natin, step by step. Divide by 5 to the negative x. And then apply the property that you can subtract exponents since you have the same base and you're dividing. So x minus the negative of x, subtract the exponent. So you'll get 2x. And then since you can get a 5 on the other side by dividing by 2, then hindi naman laging ganun na nangyayari. You will soon see that by dividing by 2, you can just have the same base for both sides of the equation. So divide by 2, you get 5 equals 5 to the 2x. And then note that 5 is 5 to the 1. So you compare the exponents now. X is 1/2. Okay, I hope you also got the same answer. Okay, next. Okay. X squared e to the x minus x e to the x equals 0. Now, there's a wrong way and there's a right way, of course. Lagi naman ganun na. But let me show you the wrong way of doing this. Transpose, This is the wrong way. And then one thing students might do after this is to divide by e to the x. Oh, I can cancel e to the x. Okay. And then they just solve that. And they further cancel x. Okay. So x is 1. Well, though that is a correct answer, but it's not the only answer. Actually, by canceling out twice, you already lose two of the solutions. You never divide when you solve an equation, provided, okay, you can only divide provided you're dividing by a constant. Like you can divide by 2, you can divide by -5, but you cannot divide by a variable y. You'll lose some of the answers. So as I shall show, actually there are two more answers than just x equals 1. So what I will be doing here is to factor out common terms, actually the GCF. And notice that x squared and x have x as a common factor, and we also have a common term e to the x. So I can factor out x e to the x. Okay? Actually, dalawa lang pala yung solution. So anyway, the term here would be x minus 1 equals 0. And so we have three factors on the left-hand side of the equation, which means that there are three possible answers or solutions, of course, at the most. So if a product is 0, remember, if you have a times b equals 0, then you get all the possible cases by equating each to 0. And you have three factors here, x, e to the x, and x minus 1. So you equate each to 0 to get all the possible answers. So that means x is 0, x minus 1 is 0, and e to the x is 0 if you are to get all the possible answers. However, this one here cannot be solved. I mean, it has no solution since, again, the exponential function in general is positive. It cannot be negative, nor can it be 0. Okay, it cannot be 0 since it's greater than 0. And so, of course, you have to show this to me in your solution for me to give you full credit. But then you just dismiss the case and conclude that this one has no solution. Okay, so that means only these two will give you solutions, and therefore your solution set contain the elements or the solutions 0 and 1. Okay, any question on this? Okay, next. Yan, pupunta na tayo sa konti, mag-touch tayo ng konti sa logarithms. Now, who can define to me what a logarithm is? Ano ang relationship? What's the relationship between an exponential function and a logarithmic function? Actually, they are what kind of functions? It's like squaring and then square rooting. It's like adding, then subtracting, multiplying, then dividing. They are inverse operations or inverse functions. They undo each other, as we shall see in the exercises that follow. Now, para makuha muna natin pala yung definition niya, gawin muna natin itong next. Okay. Without a calculator, kasi pwede namang gamitin yung calculator para sagutin to. What do you mean by log 1000? You know already, of course, from high school that if the base is not written, it's understood to be base 10 or what we call the common base. When you have E, as in this one, you call it the natural base. So log 1000 base 10 means as follows. What number, to what exponent should I raise the base 10 to get this input number or this number 1000? What should I raise 10 to get 1000? And you know that's 3. So this is equal to 3. Okay, meaning if 10 is raised to 3, I get 1000. So madali lang actually yung definition niya. Isa pa. What is the logarithm of 1 to base 13? What this means is to what number or the number to which I should raise 13 to get 1. What should I raise 13 to get 1? Obviously, it's 0. To 0, any number equals 1. We can check. 13 raised to 0 equals 1. Okay, let's try first number 10 before number 9. Siguro bigay pa ako ng mas simple pa. What is this one? Log 2 base 128. Anyone? What is the logarithm of 128 to base 2? Anyone on their screen still? Okay, 7. Okay, 7 siya. Number 10. Logarithm of 7 to base 1 over 49. Now, there are two ways you can solve this one without a calculator. One is the same approach we did for the first 2 or 3 exercises. Another is by an algebraic approach. Now, since 7 and 49 are related, okay, 49 is a power of 7. 7 squared is 49. You can do it as follows. Log 1 over 49. Okay. You think of the exponent to which you should raise 1 over 49 to get 7, right? So para rin palang nag-algebraic approach ako dito. But anyway, by trial and error, you know that 49 is 7 squared. So you know that 1 over 49 is what? 7 to the negative 2. So what should I raise 1 over 49 to get 7? 1 over 49 is 7 to the negative 2. So to make it 7, this is 1 over 49, I will have to raise it to what? Pag winanhalf ko siya, nagne-negative 1 siya. So para mag-positive 1, negative 1. So by trial and error, this is negative 1/2. Okay? Now, another approach would be to denote this by X. Okay. And then do the following technique to rewrite this in exponential form. What should I raise 1 over 49 to get 7? That's what it means, right? So if I rewrite that, I have equivalently 1 over 49 raised to x equals 7, right? We're looking for a number to which we should raise 1 over 49 to get this number. Or use arrows to see that. And then this turns out to be just an exponential equation, which we have done a while ago. We convert to the same base. 49 is 7 to the negative 2. And then multiply the exponents, and then think of 7 as 7 to the 1. Equate the exponents. So we get the same, negative 1/2. Any question on this? Okay, number 9. Logarithm of 32 base 4. Now we know that hindi eksakto no na power ng 4 ang 32. 4 squared is 16, then the next power is 4 cubed, 64. And you know that in between 16 and 64 is 32. So actually it should be 2.5, right? Your guess is 2.5. Power 2 is 16, power 3 is 64. So to get 32, which is midway, should be 2.5. But let's arrive at that by denoting this by x and then converting to exponential form. So you'll have what? 4 to the x equals 32. And then what do you do? 4 and 32 can be converted to base 2. And then equate the exponents. X is 5/2. How about number 11? Anyone can give the answer to me. What is ln? Anyone? What does that symbol mean? Anyone? Wala? Natural log, yes. N for natural, L for logarithm. I think it is the French mathematicians who coined or denoted the natural logarithm by that symbol, since in their language it has to be the noun first before the adjective. In English, it's the adjective first before the noun. In Filipino, can be either way, right? Halimbawa, kotseng pula, pulang kotse. But in English, it has to be the adjective first. So you don't say car red, you say red car. But in French, I think it has to be the noun first. Or if it's not French, it might be Latin. Hindi ko na ni-research yung history niya. So anyway, that's the symbol we use for logarithm base e. So in other words, that's just a logarithm of x, but to the natural base. So instead of having to put e all the time, we just use ln like your common base. Instead of putting 10 all the time, since it's only base 10 that you commonly study in high school, and actually noon, when there were no calculators, it is base 10 that is used. So with that, we can now give a meaning to number 11 as to what it is asking, you're looking for what? What are you being asked for here? You are looking for an exponent, right? You're looking for a number. So if we rewrite that to base e, you're looking for an exponent to which you should raise the base here to get this number here. Tama? What should I raise e to get e to the negative 4? It's so obvious. Negative 4. So the answer here is negative 4. In fact, we can generalize this. E or ln e to the x is x. This is base e, remember. What should I raise e to get e to the x? Obviously x. So actually, this is one identity that you need to commit to memory. Ln e to the x is x. In fact, ln, the natural logarithm, and e to the x, the natural exponential function, are inverse functions. So they undo each other. Okay? So that if I first apply the natural exponential function to an input number, this is the input. And then after that, I apply the natural logarithmic function, I get back to the input. Parang in-square ko siya, and then in-square root ko, bumabalik lang ako. Or in-square root ko siya, then in-square ko ulit. So the other way around also works. If I first compute or take an input number to the natural logarithmic function, I take the natural logarithm of it, and then after that, I apply the natural exponential, I raise e to that, I also get back to the input number x. Because of e and ln being inverse functions or operations. So that means we can answer number 12. Anyone? What's the answer for number 12? What is e to the ln of 5 without a calculator? Anyone can type an answer? What is e to the ln 5? Quickly. 5. The input. Then just note ln and e are inverses. So let's go back. Now we are not being asked to evaluate since the value is already given. Here we are to rewrite into a different form. So these are all exponential in form. So we are to write them in logarithmic form. So let's start with number 1. That's exponential in form. Now what is the base? The base is not, this is the exponent, right? The base is 0.5. What is the input? 4. And what is the result or the output? 1/16. Di ba? Pag nag-calculate ka, 0.5, enter mo siya, then enter mo yung 4, yung input, and then ibibigay sa'yo yung 1/16, yung output. Now, if you rewrite it or convert it to logarithmic form, syempre, yung base mo, 0.5 pa rin. Input, log to base, 0.5. However, you have to interchange the input and the output values now. So I'll put the output, and then as a result, the original input value. That's the equivalent logarithmic form. You try number 2. You may try to type that by putting like something like this. A subscript can be indicated by mathematics, putting a dash as a subscript. So if you type that, or you just put a space, for example, I can interpret this as logarithm of x 2 base 2. Or you can just unmute your microphone and state the logarithmic form. Anyone? The base is 3. Then pagpalitin mo yung input-output. Anyone? Just type. Wala. Anyone still here? Log base 3 of 2, 4, 3 equals 5. And then for number 3, it's base e, so you use ln. So here the base is e. So to write it in logarithmic form, we use also e. Then interchange 1 and 0. Or use ln. So you write it. ln 1 equals 0. This one. Baliktarin natin. Given the logarithmic form, give the equivalent exponential form. Now this one here, madali na lang. You can just use arrows to see how to rewrite it. So you can do it either in clockwise or counterclockwise fashion. So ito, naka-counterclockwise tayo. Square root of 5 to the 4 equals 25. That is to write. Square root of 5 squared is 5. Then you square it further, get 25. Number 5. That's base 10. So let me put base 10 for emphasis and so as to see where to begin with when converting to exponential. There. 10 to the negative 3 equals 0.001, correct? You just move the decimal place 3 places to the left. From 1, 1, 2, 3. Then this one here, number 6, 3 halves to the negative 4 equals 16 over 80. Okay, anyone has a question? Okay. So I'll just be doing I think 2 or 3 more here. Now that is an equation to be solved. We're solving for x. It's a logarithmic equation. These are the simplest types of logarithmic equations you will be solving. And you can solve such by converting to exponential form. It's in logarithmic form. So we apply what we have just learned. To solve this for x, we write as follows: 0.01 raised to 3 over 4 equals x. And that's x. But of course, you have to give the numerical value of that. What is 0.01 raised to 3 over 4? Well, 0.01 is 10 to the negative 2. So how do you simplify that? Multiply the exponents. Listen carefully. Multiply the exponents. So 10 to the negative 3 halves. And then how do you rewrite this? That's 1 over 10 to the 3 halves. Reciprocal, negative. You take the reciprocal and then write in radical form. How do you write that in radical form? 1 over, this is the index, so that's a square root. And this is the power, so 1 over square root of 10 cubed. And then rationalize. I mean, you can take out the perfect square. That's 10 squared of 10. Of course, if you rationalize this further, you just multiply by square root of 10 over square root of 10. And then square root of 10 times square root of 10 becomes 10. 10 times 10 is 100. But in math 21, this is an acceptable answer if required to be written in radical form. If required. Otherwise, you are allowed to give this as your final answer. Kasi hindi na yan simplifiable kung naka-exponential form tayo. But again, one more time, if required to be written in radical form, then you can give this as a final answer. You can also still give this one. No need to rationalize. Okay. One or two more. So I'll write it in, okay, so this will be the last one. I'll give you 2 minutes to try this out. Write in exponential form. Okay. So it's x squared equals 1 over 8. And what is x? There are two answers, plus and minus. Remember? Or you can write that plus minus 1 over 2 squared. In rationalized form, that will be plus minus square root over 4. Yeah, that's the correct answer, Ms. Gonzalez. Okay, that's it for this session. I will be actually discussing this again, this part, for my next class, but I will be uploading also the recorded video, since I will be discussing their logarithmic equations that are not basic. They are more complicated, okay, than the ones we just had here. And if there is no question, then I'll be ending the meeting.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.